Welcome. Thank you for joining us on The People Behind Your Water. My name is Teresa Alvarado, and I'm the manager of the Office of CEO Support and Communications at the Santa Clara Valley Water District. The Santa Clara Valley Water District manages an integrated water resources system that includes the supply of clean, safe water, flood protection, and stewardship of streams on behalf of Santa Clara County's 1.8 million people. The district effectively manages 10 dams and surface water reservoirs, 3 water treatment plants, a state-of-the-art water quality laboratory, nearly 400 acres of groundwater recharge ponds, and 275 miles of streams. We provide wholesale water and groundwater management services to local municipalities and private water retailers who then deliver drinking water directly to homes and businesses throughout Santa Clara County. So today my guest is Frank Maitski. He's the Deputy Operating Officer in the Water Utility Technical Support Division here at the Water District. Hi, Frank.
Hello.
How are things?
Good.
Good. Well, you have a very interesting division. I kind of talked already about what the district as a whole does, but what is your division responsible for?
We really support the water utility in some very key areas. I think the first thing, we also support the total organization in what we call our asset management program. And this is, we have a lot of assets that we own and we operate, and we're really developing a systematic approach to on how we operate, maintain them, and then when should we replace and repair them. So we're really looking at how do we minimize the total overall cost of ownership of these assets.
So before you move on, so when you're saying assets, you're talking about the physical infrastructure related to what you call the water utility, which is our drinking water.
That's correct, and it's the same things that you mentioned in the introduction here. It's our dams, our pipelines, our pump stations, and our treatment plants. Those are the large assets that we own and operate.
Okay, and then the other pieces, you have water resources planning?
Yep, our planners actually look at our water supply, and so they're looking at our long-term picture, how much water will we need for the community, and where are we going to get that from. And so that we just did a plan and completed it last year that really looks out to the year 2035 in terms of planning our facilities.
And that's available on our website?
That's available on our website, of course, yes.
Great. And then utility maintenance engineering?
Yep, and so we have engineering, two groups of engineers that really support the utility. The first is just our civil and mechanical engineers, and they're really looking at, from a maintenance standpoint mostly, what do we need to do to keep our pipelines operating and our pump stations operating. And then we also have our electrical engineers and our process engineers, and they're looking at those particular assets as well. Especially, people have heard about SCADA systems. These are, most of our system is controlled remotely,
right?
And so there's a lot of infrastructure that allows that to happen. So we can, 60 miles away, we can turn a valve at our dams or our pump stations, and that system allows us to do that.
That's great. So you have a lot of engineers in your group.
I do have a lot of engineers, yes, but also some planners as well.
Okay. So another unit that you manage is the dam safety program. Can you tell me a little bit about our water storage infrastructure in the valley?
Sure. In terms of our water storage, we rely on our groundwater basin. That's our main business, is to recharge our groundwater basin. However, when we first did that, the early district actually built reservoirs in both the 1930s and the 1950s.
Okay.
There was a series of dams and reservoirs that were built to store our local water. And then, of course, we grew much beyond that, the ability of our local water, which meant we have to import water from the Delta. However, we still rely quite heavily on our local dams and reservoirs to provide a good part of our supply.
Okay. And they're also used not only for water supply, but stream stewardship and recreation, the dams and reservoirs themselves?
Yep, the primary purpose is for water supply, and that's what they were built for. But we do get some incidental benefits, and even though we call them incidental, they're quite important to the community. Right. Flood management is one of those. We actually use them to help reduce flood flows downstream. Of course, our recreation program, at several of our reservoirs, we work with county parks, and they operate them for water skiing and those types of activities. And then finally, also in terms of how we operate them for downstream flows to allow our streams to run year-round, and all the species that rely on water in the streams as well. They're very important for that also.
Great. So the unit is called Dam Safety. How do we make sure that we're managing these facilities safely, these 10 dams and reservoirs?
We have an entire program that we look at just to make sure, and dam safety is very important because although they provide these great benefits, if they're not safe, then there could be catastrophic consequences. And so even though it's a very remote probability that would happen, the consequence is very high. It's more than a flood. It literally would be catastrophic in terms of its effect on the community. So we don't want that to happen. And so we really look at it a number of ways. We really start with something called a potential failure mode analysis. So we bring in experts that are on dam safety, not just our staff, but also external people, because it's good to have the external view, look at any way a dam could fail. And they look at whether it's overtopping or an earthquake or whatever it potentially could fail. Then we look at how is our program. It reviews our program to look at how we're monitoring it and what are we doing about those potential areas. And then it recommends certain aspects to our program that we include.
So, of course, dams have failed in other areas, and so we learn from those lessons.
That's correct.
And also, seismic standards change over time as new technology helps us manage our facilities. So, you said some of our dams were built, or all of them, in the 30s and the 50s. So they're older assets,
older, yes.
And how do the new standards apply to them?
And actually, that's been one of the major focuses that we have, because there is something. I should say our dams are also earth-filled dams.
Okay.
And so there's two types. Sometimes, like if you look at Hoover Dam, it's a concrete dam, so you see this nice, beautiful concrete arch. Ours are more mounds of earth that are engineered and compacted appropriately to provide an effective dam. But they could fail in a number of ways. One is overtopping if they would erode, and so that's not seismic, but that's for a large storm, and we want to make sure that we can safely carry the water around. But in terms of the seismic, that's really where we've seen changes. I want to talk about something called liquefaction, because in the 1930s and the 1950s, we didn't really understand what liquefaction, just what it did and to the extent that it could occur. So that really they weren't designed for that. And so I think what we're finding, and what liquefaction is, if you have a sand or gravel and it's wet, and you shake it very hard in an earthquake, it actually loses its structure. It turns to gelatin almost. And so I don't know, I think a classic example is the Marina District in San Francisco. If there's an earthquake, you'll see damage to those buildings. The same could happen in the material that exists in our dams. So what we found, we've done a series of seismic stability evaluations recently, and the original builders of the dam thought they did for the time, went down to competent material, but they left what's called alluvium. And alluvium is sand and gravel. When you walk down a creek bed, you'll see sand and gravel there. So they left part of that in place at the foundation of the dam, at different parts of it. They left this alluvium in place, and it is saturated. And so we have to study our dams on something called the maximum credible earthquake, which is the largest earthquake that credibly could occur. And when we look at the amount of shaking that could occur there, what we're finding is that in some of our dams where we do have this layer of alluvium, it could liquefy, which could cause the dam to slump.
So, and of course, we are on an active fault line, San Andreas, and so talk a little bit about the Department of Safety of Dams and what they have directed us to do. Sure,
and the Division of Safety of Dams is our regulator. They're part of the Department of Water Resources. They're a state agency, and they're tasked with making sure all dams in California, except the federally owned ones, but all the other dams like ours, that they're safe to operate. And so they required us to actually do the seismic stability analyses as well on our dams. They did some preliminary analysis, and I think what really forced it is as time went by and they were studying earthquakes and the size of them, that was starting to increase. You know, the maximum credible earthquake, what they thought could happen, was actually increasing. So they felt it was really time to take a good look at our dams. And they have a whole program for the state that they're going based on risk. And so they really, you know, because it's not just the San Andreas, but also the Calaveras Dam over in the Diablo Range, with both of those here in the county, they required us to actually complete these studies.
So the first one that we're, I guess, close to completing or have completed is Anderson Dam, which is our largest dam in the valley. Talk a little bit about that.
Yeah, I would, but I would like to say we're required to do studies for 8 of our dams. We've completed 6, and so now we're addressing the results of those studies. And so we found, and Anderson is The most important dam, it's our largest dam, it's our largest reservoir. In fact, it's about 90,000 acre feet, and an acre foot is an acre of water 1 foot deep. That's
Okay.
it's a volume calculation that we use for large volumes of water, like reservoirs.
Mm-hmm.
And we found at Anderson is that we do have material that's at the base of the dam that could liquefy both on the, and the way the dam is built, we have a clay core, and in Anderson it's held up, and that's in the middle of the dam, and then on either side of it, both on the upstream side and the downstream side, we have a rock fill sections. Underneath those rock fill sections is this alluvium that was left in place, and so it could slump, and what we mean by slumping is that it's kind of part of it like a landslide almost, where the crest of the dam would drop as much as 25 feet. And so that's okay as long as water doesn't flow over the top of the dam. And so what we're doing is we're required to do two things. One is keep the water level no higher than 45 feet from the top. So even if this occurs, the public is safe because the water will stay behind the dam. And then we're required to remediate the dam and to do a retrofit to correct this problem.
So in addition to us having low rainfall this year, and so people have seen the reservoirs lower than normal, we're also mandated to keep them at a lower level.
That's correct. And so, yeah, so we started the winter lower than we normally would, but then because we saw no rain, it's even, it is a pretty low throughout the county, the reservoirs this year.
So what are we going to do? What's the project to fix Anderson Dam?
So really what it is, yeah, there's a layer of material that needs to be removed or replaced, and so it's a combination of two things. What we do is have to remove part of the upstream and downstream shell. So it's a large earth-moving project, basically. We remove as much as we can, take out the bad material and replace it with good material, and then what we do is also build what's called a buttress on either side. And that's just, we just extend the dam and enlarge the dam and create a larger structure that ties it into the bedrock, and so so whatever alluvium is left in place even after that will not cause a problem. It'll be structurally sound.
So when is that scheduled to happen?
Well, these are long projects, and so the actual construction is slated for 2016. We're nearing completion. This spring we'll complete what we called our preferred alternative on exactly what we would do, and so really it's just the size of the buttress versus how much can we remove and replace versus the size of the buttress. The more material you remove, the smaller the buttress. So those were the options that we're looking at, is exactly how to do that on the upstream and the downstream side. And so once we do that, we have to then design the project and do, going through the environmental review process takes several years just to do that, because it does impact the community and it impacts the environment both, and so we have to study what those issues are and address them appropriately.
So do we have cost estimates for a project of that magnitude?
Yes, the cost estimate for this total project, which includes not just the seismic retrofit, but we do need to widen the spillway and construct a new outlet as well for various reasons, but that is about $185 million for Anderson Dam.
And how does that get paid?
There's two sources of funding. The primary source is our water rates, and so whoever uses the water pays a part of it, but we did just pass a special parcel tax in November, and there's $45 million is from that tax is slated to help fund this project.
Great. Okay. So what kind of impacts will the community experience? You mentioned the impacts to the community. What would they experience, especially those living nearby?
Yes, and as I mentioned, it is a large earth-moving project, basically. And so first of all, the water has to be lower because we have to do work on the upstream side. We are going to have to nearly empty the reservoir so that we can get to so it can work in the dry. And then as I mentioned, we'll be moving large amounts of the rock and storing it. And then we're also going to need more rock for the buttresses. And so just exactly how much still will be determined through design, but we'll have to develop a quarry operation. So we'll have to look for sites where we can get appropriate material that's close by. This is very heavy. You don't want to be hauling a lot of it around too far, and so we'll be looking at some of the original sources. If you're familiar with the area, one of the primary sources is the parking lot for the recreation program. That was actually one of the original quarry sites, so we probably enlarge that and take part of the hillside away for the dam as well. So it'll be a quarry operation. then the earth moving, and it's mostly at the toe and on the upstream side of the reservoir. So the neighbors right next to the reservoir are impacted the most, and so we'll have to work with them. There's also Cochrane Road. We may, depending on the alternative that we have, we may actually have to close Cochrane Road and then maybe even replace it as well. And so just because the road is right next to the toe of the dam, that may be impacted. So those are the largest impacts on the community.
And we didn't mention it, so Anderson Dam is on the eastern side of 101 in Morgan Hill. That's correct, in what's called the Diablo Range. And there are residents all adjacent to the facility.
Yes, there are, yes. There's new subdivisions that are fairly close, and there's some property owners that are right adjacent to the dam. And of course, there's also the county park that's adjacent to the dam as well. And so that will be closed temporarily as well until the construction's done. We look for about a 3-year construction period, so we expect to start in the summer of 2016, and it'll probably run through 2018, and at that point it'll be over, and hopefully on schedule the impacts to the community will be finished.
And of course, as we go forward, and you're already speaking with the community, where whatever project is determined, we will of course look to minimize disruption and make sure the community is fully aware and understand that ultimately this is a safety project.
Yes, that's exactly right. We do want to protect everybody who's living downstream of the dam, and to ensure that the catastrophic impact that I mentioned never happens, and that's the driver for the whole project.
So this show is entitled "The People Behind Your Water." So in that vein, when did you start here at the district, and what has been your career path?
It's been interesting for me. I started here in 1990 and more in our drinking water quality program. I was there for several years, and then I took a position in in the water utility in what's called, I forget the name of the division back then. I took a position in water resources management at a variety of planning in the water supply side as well. Worked with our our stormwater program, represented the water district there. Then moved over to what's called our was general services. It was called technical services at one point, which is again a lot of support services like real estate survey, construction management, our purchasing, our fleet, our facilities, so more in the administrative area and some of these support services. And then about 3 years ago, I moved back to the water utility directly and into the position I'm in now.
And what is your educational background?
I have a Bachelor of Science degree in Environmental Engineering from the Pennsylvania State University.
Okay. And the reason I like to talk about people's career path here is I want the public to understand that there are opportunities in water resources. It's an important field, and not only engineers work. We have communications people, we have administrative people, finance folks, legal, real estate. All those functions are really core to what we do.
Biologists.
Sure.
There's a lot of the technical sciences as well are represented here.
Great. So what can we expect next on the project itself? Is it coming before the board anytime soon?
The next step really is we have a draft of the alternatives, so the preferred alternative should be coming up in March or April. Okay. And that's really where we'll be focused on exactly what project we intend to build, and then that will go out to the community, and we'll start the environmental process from that standpoint.
And people can get information either by watching the board meeting on the web. They're streamed live on the web, and you have a whole web page on our website. And
our project manager is there, and he's ready to answer any questions anybody would have. We also access Valley Water. That's the way we work with the community always. If they have specific questions about anything, they could always ask a question there, or go to our webpage and just educate themselves on both the dams, dam safety, and the project itself.
So Access Valley Water is our online customer service center. It's accessible from our main website, and folks can submit a question, a comment, a complaint, or a compliment to any of our staff on a lot of our programs. So it's a great tool to use, and we get back to folks in a very quick order. So
yes, we do.
Thank you so much, Frank. Very interesting work, and we really appreciate your time.
And thank you.
So again, there's project information about the dam safety program at valleywater.org/dam safety. And since this is March, we wanted to encourage you to find out more about our precious underground water supply. It is, Frank mentioned our groundwater basin, and it is National Groundwater Awareness Week. And to celebrate World Water Day, which is recognized each year on March 22nd, we encourage you to find out about both of these issues on our website. And in honor of National Groundwater Awareness Week, stay tuned after The People Behind Your Water for a really fun short animated film called The Groundwater Story from our friends in King County up north. And it's a great way to learn about your groundwater basin and also share with your kids the importance of keeping our groundwater basin free of pollution and appreciating that underground resource. And as always, you can sign up for our e-newsletter. You can go to our website and there's an envelope icon. You just click on that and you can sign up for our monthly e-newsletter. You'll hear about important projects like the ones Frank described. You'll also get information about our board meetings, grant opportunities, tours and open houses, films. We often host films here as well. So please stay in touch with us at the Santa Clara Valley Water District. So thank you for joining us, and we'll see you next time on The People Behind Your Water.
Hey, what happened to my water?
There's something here that you should know. The story of water from down below.
Oh, I'm groundwater, I'm all around. Most of your water is underground. The water we have is all the same. I'm used over and over again. I surrounded the castle with a watery moat, and I float along under Huck Finn's boat. I once dripped down as dinosaur drool, and now I'm the cool that fills your swimming pool.
Feel the drops of snow and rain, an age-old cycle again and again. Groundwater under the ground, groundwater flowing down in the ground. Groundwater all around, groundwater, don't you know why we should care? The water we use is everywhere.
Riding along the aquifers, deep down under where no one stirs. I feed the lakes, streams and land. I'm pulled by wells, I'm in demand. Flowing along the great barren treasure, slipping through space too small to measure. I may start off with an oily sheen, but the dirt and rocks help keep me clean.
Swallow and swim, shave and spray. We all use water every day. Some for fishes, some for dishes. But is there enough for everyone's wishes? Use it. Groundwater, don't abuse it. Groundwater, we use our groundwater every day. Let's make sure it's here to stay.
Oh, rainy days, I must lament the troubles I have with tar and cement. I can't feel the ground if I can't get through. I'm groundwater, my power is vast. But waste and pollution keep me from my task. If we're not careful, clean water won't last.
That's some help. We can't carry on. What would we do if the water is gone? Every time you brush your teeth, remember the water underneath. Next time, wait, stop, and think before you dump stuff down the sink. Do your part for water power. Learn to take a shorter shower. Stuff that makes your grass look swell will end up later in your well. Protect
From groundwater, I'm all around. Most of your water is underground. The water we have is all the same. I'm used over and over again. I surrounded the castle with a watery moat, and I float along under Huck Finn's boat. I once stripped down as dinosaur drool, and now I'm the cool that fills your swimming pool.